Alright, this is the last video for three-dimensional figures. This is a cylinder removed from a cylinder. So instead of having objects sort of one on top of the other, we're kind of removing one from the other. So it's going to look a little bit different. So once again, we'll start with the volume of the cylinder. So this cylinder here, I'll just kind of scribble over it. That cylinder is being removed from the bigger cylinder. So I'm going to be referring to these as big and small. So we have the big cylinder and the small cylinder. So what we're going to do for volume is we're going to take volume of the big minus volume of the small. Volume formula for a cylinder is pi r squared times height. And so it's the same formula here, pi r squared times height. So the only thing that's really going to change here, the height of the cylinders of both cylinders, the big and the small, are both the same, 14 millimeters. The only thing that's changing is the radius. So the big cylinder has a radius of 6 millimeters and a height of 14. And this figure here, the smaller one, it's kind of tough to tell, but that has a radius of 2 millimeters. So we'll say 2 squared times height is still 14. So you can actually type all of that into the calculator at once. If you want to break it up into sections, that's fine too. The volume, if I kind of break this up, ends up being 1,582.56. This ends up being 175.84. And when I subtract those values, I get a volume of 1,406.72. That would be millimeters cubed. So that was volume. For surface area, it's a little bit more complicated. So I'm going to kind of walk you through. I'm going to do the surface area of the big one. So everything, top, bottom, and then the outside, the lateral area. So we're going to do the surface area of the big thing, but then we're going to subtract off the area of this and this. So I'm just subtracting those two circles, not necessarily the inside part, just the circles. So I'm going to say minus, and I'll just say area of top and bottom. And then what you need to imagine is that this is sort of hollow through here, and then I want to put wrapping paper inside this part. So now I need to cover the lateral area of the small cylinder. So not the top and bottom, but just the lateral area of it. So surface area of the big cylinder uses the formula 2 pi r squared plus 2 pi r h. So let's go ahead and fill those numbers in. So 2 pi, the radius of the big one is 6, plus 2 pi 6 times 14. So when I simplify all of that out, I get 753.6. The area of the top and the bottom circle, so just the area. If you look at your formula sheet, area of a circle is pi r squared. But it's the same circle. It's the top and the bottom. So I'm going to take that area and multiply it by 2 because there's two circles. So we'll say this number here minus 2 times pi. So the radius of the small circle was 2. So when I simplify all of that out, I get 25.12. And then I'm going to add to that the lateral area of the small circle. So again, if you look at your formula sheet, the lateral area of a cylinder is 2 pi r h. So that is going to be 2 pi 2 times 14. And when I simplify all of that out, I get 175.84. And now basically just sort of combine these numbers here. So subtract and then add. That gives you a total surface area of 904 0.32 millimeters, squared. Alrighty, that concludes the videos for 3D figures. Thank you for watching.